Hello people, hi, what's up? So in this new video we will discuss about a new pattern or the application of all the possible questions in your geometry section of your CAT examination. Again, like in the previous video, we will not discuss about geometry, area, length and volume. We'll simply discuss about two important elements. One is going to be your common ratio and second is going to be your geometric progression, which you must have done in the topic of progressions, that is AP and GP. If you can understand these two possible patterns, then possibly all the difficult level question you'll be able to crack in like seconds. This is my bet. So let's begin. Okay, so in this pattern of questions wall, what you can expect is a polygon in a circle. I can see that a typical question will look like that what is the maximum radius of a circle that can be inscribed in a square, or what is the maximum diagonal of a square that can be circumscribed to a circle. In a simple way, what I can see is either a circle or a square, or a square in a circle, or a circle in a square. So a possible combination of circle and square is the matrix that we have to solve now. Alright, now let's take the first case in which all what you can see is a square within a square, and any two consecutive square has been formed by using the midpoint of the previous square. Now let's take the first case in which all what you can see is, let's assume the length of the bigger square to be as 2. If the length of the bigger square is 2, the area for the bigger square is nothing but we all know it's going to be 4. And if you have to calculate the area of the inner square, how would you do it? Okay. Now you know this is the midpoint, so you know this is going to be 1, this is going to be 1, 1, 1, 1, 1, and this is also going to be 1 and 1. If this is 1 and 1, you know this side is going to be square root of 2, as this is going to be 90 degree. If the side of the inner square is going to be root 2, what is going to be the area of the inner square? It's going to be root 2 square, is nothing but 2. Can you see how the values are changing? The bigger square is 4 and the inner square is going to be 2. It is just reducing by 2. What's going to be the area for the third square? It's going to be 1. The fourth square will be half. The fifth square will be nothing but 1 by 4. If you have understood this pattern, this is nothing but a geometric progression where all the consecutive values is just reducing by half. All the possible values just reducing by half. Now imagine in this case, if the question is find the ratio of the area of the fourth square to the area of the fifth square without doing anything, even if you don't know the length of the bigger square or the inner square, you can very well say the ratio is going to be nothing but 2 by 1, because you're comparing with the fourth and the fifth. Fifth is going to come interior. Fifth is going to be the interior square. If I ask you find the ratio of the sixth square, find the ratio of the sixth square to the fourth square. What is going to be the ratio of the sixth square to the fourth square? Now you know the ratio, the fourth square and the fifth square is nothing but half. It's nothing but half. Fifth to sixth is again nothing but half. So you all know the ratio is going to be nothing but half ka half, which is nothing but 1 by 4. Or any two consecutive square, the outer square to the inner square is always having a ratio of nothing but 2 by 1. It's going to be a ratio of nothing but 2 by 1. The outer square to the inner square is always nothing but 2 by 1, because it's a geometric progression. Now if the question is, had it been the question that find the sum of, let's say the question is find the sum of all the areas of all the square that is inscribed in this. Find the sum of areas of all the square that can ever be made in this, which is simply mean to say is, let's imagine there's a square inside this. You got a square inside this, you got a square inside this, and the square is just going on, and the square is just going on. You all know this is nothing but a sum of an infinite GP. A sum of an infinite GP is given by which formula? A divided by 1 minus R. What is this R? It's a common ratio. And this common ratio is nothing but in this case half. What is A? here is nothing but the first value, which you all know it's going to be, let's imagine in this case it's going to be 4. So it's going to be 4 minus 1 by 2, which is nothing but 4 divided by 1 by 2, which is nothing but 8 square centimeters. This is the sum of all the possible square that can ever be made inside this. That's the first pattern. Typically what I want is understand the second pattern and then we'll mingle both to solve all the difficult level questions. Okay, so the next question that you can see, the next pattern is nothing but a circle in a square in a circle, a circle in the next square, a square in the next circle. So it's a combination of your square and circle. It's a combination of a square and circle. Now imagine a case, let's assume that the length of the bigger square is nothing but 2. If the length of the bigger square is 2, what is going to be the area of the square? It is going to be 4. If the area of the bigger square is 4, and the question is find the area of the first circle that you can see here with this radius r is going to be what? Now we all know if the length of the bigger square is 2, all I can see is if this is the common diameter, this diameter will also be nothing but 2 because the length of the square is 2. If the diameter is 2, what is going to be the radius? Radius is nothing but 1. If radius is 1, what is going to be the area of the circle? Area of the circle is nothing but pi into 1 square, which is nothing but pi only. So now if I ask you, find the ratio of the first square to the next consecutive circle, you all know the ratio is going to be nothing but 4 by pi. You all know the ratio is nothing but the ratio is going to be simply 4 by pi. Now imagine a case, now in this case, now if I ask you to find the area of the next square that is now inscribed in your circle, or the bigger circle is going to be what? Now you're comparing the bigger square, this square versus this square. Now what happens if I remove the outer circle that you have here? What happens now, as of now, if I compare this, I can visualize a figure which is just as simple as this. A square, a circle within a square, and then again a square. What happens now if I remove this circle now? If I remove the circle, I can visualize a figure which is as same as the previous figure like this. All what you're doing is rotating this square by 90 degrees to form a new segment which is just like this. Or we all know this is nothing but the pattern that we have just seen. The ratio of any two consecutive square which has been formed by using the midpoint is going to be what? Again here in this case? You all know it's a geometric progression. Now if the ratio of the area of the bigger square was 4, this square is going to be 2. This square is the third square is now going to be 2. What is going to happen about the second circle that you can see in the figure? Something about this figure. Now if I have to find the area of the next circle in the figure, without doing anything, I know the area of the next circle is going to be nothing but pi by 2. All what I can visualize now is the area of the first square. If it is 4, the area of the next circle will be nothing but pi. The area of the next square that is inscribed in the circle will be 2, and the area of the next square which is again inscribed in the square will be nothing but half of this pi, which is nothing but pi by 2. What about the area of the next square that you can see in here? It's going to be 1, because all the square in this case will be nothing but a series of GP where the ratio is always half, and the corresponding ratio of any two square is going to be 2:1. Same is the case with circle again. The circle, if you can see here, the circle again, if it is pi, it's pi by 2. What happened to the next circle? The next circle will be nothing but pi by 4. Why is it so? Because it's always a GP of a ratio, again, 2:1. So all the possible square within a square will have a ratio of 2:1. All the possible circle within a circle will have a ratio of 2:1. And all the possible consecutive square to the consecutive circle will have a ratio of 4 by pi. That's why I have named the series as 4 pi 2 series. So it's a series of 4 pi 2 series. Awesome. So if you have understood this pattern, then possibly all the difficult sum that we'll see now, you will be able to solve in like seconds now. Let's read the question. The question says, a circle is inscribed in a square ABCD, where another square PQRS is inscribed in the circle in such a way that the vertices are at the midpoints of ABCD. This is repeated by inscribing another circle in PQRS and another square in the second circle in such a way that the vertex is always the midpoint of the PQRS. This is repeated infinite times. Find the ratio of sum of all the areas of the square to the sum of all the areas of the circle. This is just the sum that we have just done by taking the geometric mean or the geometric progression series. If you have to visualize a diagram, possibly I don't want anyone to do it, but even if you do it, this will look like a square that you have. Within a square, you got a circle. Within a circle, you got a square. Within a square, you got a circle. Within a circle you got a square, and again the series just goes on. The series just goes on. Now you know they are talking about the infinite times, which means they want the sum of all the square to sum of all the circle, which you all know is nothing but a 4 by pi series. Which you all know it's nothing but a 4 by pi series. Why is it so? Now if I talk about, now if you know that if you have to find the sum of all the possible square, the first square has having an area of 4, the common ratio is 1 by 2, so the sum of all the possible square is nothing but 4 divided by 1 minus 1 by 2. What about the circle now? The circle will be nothing but pi divided by 1 minus 1 by 2, because all the possible circle will be nothing but half, half and half. I can see these two values getting changed, and again this ratio will remain constant as usual. This is what I am trying to explain you. The ratio is nothing but a series of 4 by pi. The ratio is nothing but a series of 4 by pi. So whenever you see a question which is nothing but a polygon in a circle or circle in a polygon, it is all nothing but about a ratio of 4 by pi. Good one. This is Calc 2005 question. Okay, let's take the next question. The question says, the figure below shows two concentric circles with circle O. PQRS is a square inscribed in the outer circle. It is circumscribing the inner circle, touching the points of B, C, D and A. What is the ratio of the perimeter of the circle to that of the polygon ABCD? Now, irrespective of anything, whenever you see a circle and a square, for sure you have to understand this is nothing but a series of 4 by pi. Okay, now they are talking about the perimeter of the outer circle, that is this, to the polygon now, to the polygon which is now ABCD, which is nothing but ABCD, which is nothing but now ABCD. Now all what you have done till now is you have taken a square and within a square you have made a circle. In this particular figure, all what they have given is starting with a circle. What happens when you get a figure like this? There's nothing to worry about. All what you do is, let's make an outer square to make my life little easy. Just to make my life little easy. Just to make my life little easy. Okay. Now you know, if the outer square is nothing but having an area of 4, the inner circle will have an area of pi. If the inner circle is having an area of pi, the next circle, the next square will have an area of 2. And the answer is over. And the answer is just over. The question is find the ratio of outer circle to ABCD. You know, the outer circle is going to be pi and the inner square is nothing but 2. So the answer has to be simply pi by 2. This is how quickly you can solve if you have understood the pattern of various geometrical figures that you have inside. This CAT 2010 question. Okay. Alright, so let's see. This is what happens in CAT is like they'll give you various patterns. A pattern is nothing but a simple template and making a new variety of sum. In CAT 2010-9, you had a question. 4 identical coins are placed in a square. For each coin, the ratio of area to the circumference is same as the ratio of circumference to the area. Find the area of the square that is not covered by the circle. Okay. There's one important hint what they are giving you. The hint is nothing but circumference to area is as same as area to circumference of a circle. Which kind of circle in which kind of circle can you see the ratio of circumference to area is as same as the ratio of area to circle? It is going to be possible only in a circle with a radius of 2. Because if the radius is 2, my circumference will be 2 pi into 2 and my area is nothing but pi into 2 into 2, which is nothing but the same. And both the ratio is nothing but pi r square. Now you know, all you know is nothing but is the radius of this circle is nothing but 2. If the radius is 2, the diameter is going to be 4. If the diameter of one circle is 4, the diameter of 2 circles will be how much? The diameter of 2 circles is nothing but 8, which is now nothing but the length of the square. Now imagine a case in which the length of a square is 8. If the length is 8, what is going to be the area of a square? The area of a square is nothing but 64 now. The area of a square is nothing but 64. Now if you actually imagine this figure what they have given you is nothing but 4 concentric circles within a square. This square is having a dimension. If you make matrices here, if I make 4 quadrant here, how many quadrant have I made in this square? It is something called 1, 2, 3, 4. And how many circles we have? 1, 2, 3, 4. This figure is exactly as same as a bigger square in a bigger circle in a simple square. This is as same as this. Even if I give you 16 by 16 matrices, which means 16 particular quadrant and 16 circle, this will be again as same as this. If I give you 32 by 32, it is again as same as 1 by 1. It is again as same as simply 1 by 1. And now see the question. The question is, find the area of the square that is not covered by the coins, which simply means they are asking you to find the area of this particular region, this particular region, this particular region, this region, this, and finally you have this region. So all the region which is just not covered by the circle. Now if you understand this very carefully, this is nothing but again a simple square in a simple circle in a bigger square, where all the 4 possible small square is nothing but one big circle, is simply but one big circle, and all the uncovered area within all the simple circles is nothing but all the areas that you can see here, all the areas that you can see here, all the area that you can see simply here. Which one is more easier to solve, this one or this one? I would say this one, though both the things are same, but you will find this much more easier. Now you know the area of a bigger square is nothing but 64. Okay, you all know if it is a concentric circle within a square, the ratio of area of a square to a circle is nothing but, we have just solved, is nothing but 4 by pi. Will be nothing but 4 by pi. So the question is, this is 64. What is this? You know the ratio has to be 4 by pi. So how many times we have multiplied 4? This is 16. So this value has to be 16 pi. The answer is over. You know, the circle is having an area of 16 pi. The square is having an area of 64. So the region which is just not covered by the circle in the square is nothing but 64 minus 16 pi. which is nothing but 16 common outside 4 minus pi. Which option will you mark? You will mark option number C. So this is all the possible diagrams. Whenever you see a value, a polygon in a circle, it has to be nothing but a 4 pi diagram. Will be nothing but a 4 pi diagram. That's Calc 2009 question. Okay. Alright, so I hope you have enjoyed this video. The objective is you go back and open all the previous year CAT papers and identifies all the such similar patterns. The similar patterns, at least in this video, was nothing but a geometric progression of a square within a square or a circle within a square with the ratio of nothing but 4 by pi. So all those values, nothing but a ratio of 4 by pi questions. Alright, so again, do hit on the subscribe button that you can see on the video and get in touch with us on the given numbers. Thank you so much. All the very best.